Okay, now we're going to practice putting our molecules together, taking into account these directing group effects. So here we have a molecule, and we're going to sort of take a look at it and figure out in what order we are going to add our acyl group and our bromine, right? So we're going to synthesize this molecule from benzene, okay? So when looking at this molecule, first we need to look at the substituents on the benzene ring and decide what directing group activity do they have. So we have a bromine group here and we have a ketone group here, right? So remember, think back to the directing group scale, whether it's an activating or a deactivating group, whether it's an ortho or a para director. So here we have bromine, and bromine is a deactivating group because it's electronegative. However, because it has all these lone pairs, it is an ortho-para director. Okay, so if we add it first, it's going to add functionality to either an ortho or a para position first. Okay, we have our ketone here. Our ketone is also a deactivating group because we can remove electron density from the benzene ring by resonance with the carbonyl. Because it's a deactivating group, it is now a meta-director because we are removing electron density from the ortho and para positions, and while leaving the meta positions alone. So it is a meta-director. So when we look at this molecule, we also need to take into account what is the relationship of these two functional groups that we have, right? And can we use one to direct the other one onto the benzene ring in the correct position? So if we look at the relative position of these two functional groups, right, they are in a 1-4 relationship to each other, so they are para, right? So we're going to want to design our synthesis so that we add an ortho-para director first and use that to add the other functional group. Okay? So in our synthesis, we're going to want to start with benzene. Right? And we have to decide which one of these are we going to add first. Because we have a para relationship between these two substituents, we're going to want to add the bromine first, because the bromine is going to help us position our ketone group. Right? So our first step of our synthesis is going to use molecular bromine and some Lewis acid catalyst like iron tribromide, right? And so this is going to add the bromine to the benzene ring. And because we have nothing on the benzene ring so far, it doesn't really matter where we put it, we're going to add one bromine atom here. Okay? So now we have bromine attached. We know it's an ortho-para director, so we are going to, when we do further reaction with this, we are going to get reactivity either at the ortho or at the para position. Because we have a bromine here, the ortho positions are somewhat blocked, so we're going to primarily get reactivity at that para position. So if we want to go ahead and add our ketone group here, we're going to do a Friedel-Crafts acylation reaction. So we're going to use an acid chloride. So here's acetyl chloride, and we're going to do this in the presence of a Lewis acid like aluminum trichloride, right? And ultimately, the product of this will be where we have bromine and our ketone groups para to each other in the benzene ring, right? And this is accomplished because we add the ortho-para director first, followed by the ketone. If we did it the other way around, we'd first add the ketone, we would have a meta-directing substituent on the ring, and then when we try and add the bromine, we would get the alternate product. So we want to do it in this order in order to get this compound.